BCHCL 132 practical file with all experiments. It is a course code of BSCG program in GNU. So I will show here all the 6 experiments one by one. Here it is the first experiment. The object is to determine sodium carbonate and sodium hydrogen carbonate present in the given given sample. In your laboratory courses, you have to perform this experiment in your chemistry lab. I will show here also the principle. Sodium carbonate is a salt of weak acid and strong base. When such salts are dissolved in water, they behaves as bases due to the basicity of conjugate base CO3 to ion. So here there is the reactions. Here you can see the form of benzoate in acidic solution with colorless, and the conjugate form in basic solution with pink phenolphthalein. Here in this experiment you have to use the two indicator. The first indicator is the phenolphthalein and the second indicator is the methyl orange. Phenolphthalein is a colorless indicator. As you know, the molarity is the number of moles in solute upon the volume of the given solution in liter. That is the called molarity. Observation mass of weight bottle and etc. The molarity of the NO2CO3 sodium carbonate is 0.053 mole per liter. Here the calculation standardization of hydrochloric acid solution. When you perform this experiment, first of all you have to take a weighing bottle. Here is the mass of weighing bottle is the 5.6 gram, and in this experiment first of all you have to make the standard solution. After it, the next process. Finally, the result. Here you can see the molarity of the NO2CO3, the molarity of the sodium carbonate is the given solution 0.0031 mole per decimeter cube, and the molarity of the sodium carbonate in the given solution, that is the 0.0306 mole per decimeter cube, and the strength of the sodium carbonate is the given solution 0.328 gram per upon decimeter cube. And the strength of the sodium carbonate in the given solution, that is the 2.57 gram per decimeter cube. And the next that is the next experiment, and the object this experiment is the to estimate of the oxalic acid in by redox titration. Here you can see what is the oxalic acid and how we estimate this oxalic acid by redox titration. That is the principle that is the potassium permanganate in an oxidizing agent and get reduced in the presence of a suitable oxidizing agent. For example, oxalic ions C2O4 2 minus, the permanganate ions Mn4 minus get reduced to Mn2 plus ions in the acidic medium and the Mn4 plus ions in the neutral or alkaline media. And then as you see, as you know, what is the oxidation? When any atoms that lose the number of electrons, that the atom who who, who lose the electrons, that is called the oxidation. Or the atom who's gain the electrons, that atom called, this process is called the oxidation or reduction. And that atom who gain the electrons, the atom is called the oxidizing agent. And the atom who who lose who lose the electron of that atom is called the reduction agent. So that is the real process of the this oxidation agent and reduction agent, reducing agent. KMnO4 is the potassium permanganate. As you see, the KMnO4, the potassium permanganate is also the oxidizing agent, and it act as a as a self indicator. There is no external, there is no internal indicator is present here. KMnO4 is also work also act as a self indicator. A slight excess of NO4 had the end point impact the distinct pink color to the solution and therefore act as a self indicator. And net the observations. Here you can see and you can prepare your also practical files. It will help you to prepare best and to gain the maximum marks in your practical exam. खींच रहे हैं. And the last, you can see the strength of the given oxalic acid solution is the 1.375 gram per decimeter cube. And the next experiment, that is the to estimate iron second ions by chromatography using internal indicator. There are three types of indicator are present or exist. First, that is the self indicator. Second, that is the internal indicator, and the third, that is the external indicator. The KMnO4 is the also work, also act as self indicator. And in this experiment, I will discuss that is the internal indicator. And the potassium, the principal potassium dichromate is an oxidizing agent in acidic medium. And react according to the following of reaction to give chromium third ions as the reducing product. The Fe2 plus ions when titrated with the dichromate get oxidized to Fe3 plus as per the following equations. It is the equation which extracts the oxidation reaction. And the factor 6 is present there. There is mole of potassium dichromate react quantitatively with the 6 mole of iron second. The 1 mole K2Cr2O7 is equal to 6 mole of ferrous iron second. And the indicator, this these indicators are colorless in the reduced form and become intensely colored and on oxidation, deep blue violet with the diphenylamine and red violet with the sodium diphenyl sulfonate. So that is the reaction diphenylamine which act the oxidation, and that reaction perform here. You can see, and you can make your practical file will hand in this, and the practically in this final day when exam perform, you have to give your viva in the front of examiner. So you have to perform all the you have to clear all the topics very well. FAS, that is called the ferrous ammonium sulfonate, and that is also called as a Mohr salt. Hmm? The and if I discuss about the ferrous ammonium sulfonate, what is the formula? That is the FeSO4 dot NS4 cohort twice SO4 dot 6H2O. And as a result, the strength of the ferrous second ions in the given FAS solution, FAS होता है ferrous ammonium sulfate net solution, is found to be 5.29 gram per dm cube. And the second and the next, that is the fourth experiment, that is the from 3 book object to estimate water of crystallization in Mohr salt. In this experiment you have to solve that the Mohr salt, that is also called the ferrous ammonium sulfonate principle. Let there be x number of hydration in the Mohr salt. Mohr salt is the salt. In this salt hydration also present. Permagnometry, what is the permagnometry? The permagnometry is the also is found from the permagnet of KNO4, that is also called the self indicator. In this experiment you have to also use the self indicator as the permagnometry, that is the KNO4. And this experiment KNO4 is the field in the burette. Observation table. Calculations, estimate of strength of potassium permanganate. And the next fifth experiment is to estimate of copper second ions iodometrically using sodium thiosulfate titration with iodine, that is called iodometry. And there is two. First, that is the iodimetry, and the second, that is the iodometry. Iodimetry, that is the titration with iodine. And the second, that is the iodometry, titration of iodine with product by the chemical reaction, that is called the iodometry. Here we use the potassium dichromate in the place of more salt, and 0.09 or 0.1 gram molar mass of K2Cr27, that is potassium dichromate, to 94.19 gram per mole. That is the two observation table. First observation table, that is the from of known solution, and the second observation table, that is the record from the unknown solution. Known solution, that is called also as the standard solution, the solution which I made from the dichromate. Okay, let's move the next calculations, and the next I will show what is the result of this experiment. So results, that is the strength of copper second ions in the given solution is found to be 0.99 gram per dm cube or 1 gram per dm cube. Okay, चलिए let's move on the next experiment. Okay, so one experiment missing here, but no matter. So I hope it will help you. So thanks for watching. Ram Ram.